I'm Kumar. Welcome to my series on functions. In this video, we'll discuss about how to identify that the relation is a function or it is not a function. So that is prime focus for this particular video. Before we get into this, I will actually discuss with you some examples so that you understand the concept, and then we'll have practice multiple choice test questions for you. I can show you the 6 questions which we are going to work with. Here is our question number 1, in which we have taken few equations. You need to explain if these relations represent a function or not. Now, in most of the multiple choice questions, you will see there will be only one correct answer, but as a change, in my case, there could be more than one correct answer. Now also, it is a good practice to understand the topic better, so you may do something additional to understand. For example, in question number 1, you may sketch graph of each and then explain why it is or it is not a function. Perfect. Now this could be adopted for all the questions which you do in my videos. Here is question number 2, in which we have taken in the set form all the relations, and you need to figure out which one of these is not a function. In question number 3, we have given you word statement. As you know, a relation can be represented in many different ways, and just based on that, we have 6 questions for you. In question number 4, we have given you 2 variables a and b, where a is independent variable and b is a dependent variable. You need to figure out from the given equations which ones represent a function. In question number 5, we are discussing about domain and range. Now, domain and range of relations are provided to you. You need to think and reason out which one of these will be a function and which one of these will not be a function. Question number 6 is very similar to the question we had earlier, question number 4. However, here some additional strategies may be applied to answer. So I hope these questions you find them interesting and useful. Now let's begin with the concept, take up some examples, and then solve these test questions. So let's begin by understanding what is a relation and what is a function, and how to identify that a relation is a function or it is not a function, correct? So in short, I can say that relation is basically what? Relation is set of input and output. Right? So in short, we can say relation is a set of input and output. Now how about function? So first thing very important to understand is that function is a relation, right? So every function is a relation, okay, in which we have a condition. What is the condition? That each input has only one output. Has only one output. Now that is what makes function different from relation, correct? So taking few examples, let's take some graphs. So in graph it is very easy to show whether the given graph represents a function or not. It is important to understand that all these graphs will represent a relation, correct? Now whenever we plot a graph, we'll have independent variable along the x-axis, let's call it at x, and the dependent variable on y-axis. So I'm writing x and y for all these graphs. Now I'll try to show you different types of graphs. One, let's make a continuous graph. For example, something like this. Now in this particular graph, for every value of x, we have unique value of y. Okay, so this one is a function. Now here's another continuous graph. Now in this particular graph, what you observe is that for a value of x, let us say 0, we have these different values of y. Since for one value of x, we have different values of y, it is not a function. Perfect. So what we observe is that vertically, if the graph cuts through more than one point, then it is not a function, and we call this as a vertical line test. So from a graph, vertical line test can easily tell us whether the given graph represents a function or not. Now let's consider a few points, right? So if I have points like this, in that case, we have 2 points on the y-axis. For x equals to 0, we have 2 values, and therefore, this is also not a function, correct? However, if we had points like this, in that case, each x value has only one y value, and so this is a function. And the first one, as I explained, is also a function. So what we learned here was that if I draw a vertical line, and if it goes through more than one point, for example, here there are 3 points, and here this vertical line goes through 2 points, so that is not a function. Is that clear? However, if it only goes through one point, as in these 2 cases, then it is a function, correct? So this is the basic criteria to distinguish between a relation which will be a function or not a function, right? Now let's take some more examples. Now when we're talking about examples, I'll try to give you, first let's do mapping diagram, right? So functions can be represented in many different ways. Mapping diagrams is one of them, where we kind of relate things like this, right? Now if I do a mapping diagram like this, or even connect 2 points in the domain with same point in the range, even then it is a function, right? We may write some numbers here, for example 1, 2, 3, 4, 5, and A, B, C, D there, but that really doesn't matter. Now in the test questions, what we normally do is give you an example, something like this. And I'm going to draw the same thing, right? So let's say like this, right? However, I may place the arrows on the other side. Do you see that part? Same example, arrows on the other side. Let's say this is 1, 2, 3, 4, and this is A, B, C. Now in this case, A and 1 is one set, and we also have A and 2 as the other set. Since arrow is pointing in this direction, in this case the domain or the independent variable is on your right. So this set contains these two input-output combinations where the value of A has two outputs, 1 and 2, and therefore it is not a function. You understand, right? The other points, of course, you could write here as B3 and you could write C4, right? So if I write it in the set form, in that case you find that A repeats, right? So if A repeats, then it is not a function, correct? What else do you note here? Well, there are a few things related to domain and range which we should also see, right? So in our first case, where we have a function, what is the domain? Domain in our first case is 1, 2, 3, 4, and 5. We have 5 elements in the domain. As far as the range is concerned, we have A, B, C, D. 4 elements, right? So the number of elements in the range is less than domain, it is a function. However, here, if we see domain and range, so what is the domain here? Domain in this case is ABC, and the range is 1, 2, 3, 4. You see the number of elements in the range is more, clearly indicates that some element in domain must be associated with one or more, and therefore it is not a function. Is that clear to you? Correct? So if you are given a mapping diagram, you have to focus on the direction, right? And then answer. Perfect. Now let me give you other example where we will take equations, right? So if I have an equation where I have x squared plus y equals to 3, let me take another equation which is x plus y squared equals to 3, right? Now can you tell me out of these which one is a function and which one does not represent a function, right? Well, to answer this question, we need to do what? We need to isolate dependent variable. Which is y in our case. So whenever x and y is given, we assume x to be independent, y to be dependent. Okay, so if I isolate, I do get what? I get y equals to 3 minus x squared in the first case, and the other case I get y equals to 3 minus x. This is y squared actually. So if I want to find what y is, so I get y equals to, I have to square root, right? 3 minus x. So whenever you square root, you will write plus and minus. So for the values of permitted values of x, we'll actually get two values of y. Do you see that part? So clearly, the first one is a function, and this one is not function. Is that clear to you, right? So 3 minus square root of 3 minus x, right? So if you take a graphing calculator and try to graph this second function, a relation, what will you get? Well, here basically for every one, the value of x can only be 3 or less, right? It cannot be more than 3, correct? 3 or less. So if I put this as 3, x is 3, then we get y equals to 0, right? So if I put x as 3, let's say y equals to 0, and if I put x as 2, then we get 1, right? So we get 1. But we get plus 1 or minus 1, because we have plus and minus 1. So we have a graph which is kind of like this. So that becomes the graph. Clearly, you can see that for any x value in the domain, we may get more than one value of y. Does make sense to you? So it fails the vertical line test. And therefore, this is not a function. It may be a relation. It is a relation, but it's not a function. However, in this particular case, if you sketch this graph, let me sketch it here on the side, minus x square moved 3 units up, right? So basically, we have a graph which is kind of like this. So that's a parabola. It is a function. Do you see that part, right? So that represents a parabola. However, this represents a relation which is not a function. Is that clear to you? So in the examples which I have taken, we'll talk about equations and the cases where we are also talking about domain and range and then figuring out whether it is a function or not. So these are kind of tricky questions for any test paper. Now I hope you got all the concept. So now take your time to answer these questions. Let's again get back to our multiple choice questions. Here is your question number 1. So you can actually pause the video, answer this question. Remember, more than one could be the right answer, right? Now let's try to answer the very first question, which is, which of the following relations are not a function? So we're looking for not a function. The first one is y equals to x. It's kind of important for us to understand them and then answer. Y equals to x is a straight line which goes diagonally, right? Clearly, it passes the vertical line test, and we know this is a function, right? So this is a function. Second, we have x equals to 1. So when I say x equals to 1, that really means that for all values of y, x value is just 1, right? So it is a line which is kind of like this. So the first one was the graph of y equals to x, and this is graph of x equals to 1, okay? Is this a function? Well, it is a vertical line. This is not a function, so we'll circle this one. Okay? It is not a function. For every value of y, we have only one value of x. So it fails vertical line test. There's so many values for x equals to 1, right? Then the next one for us is y equals to 2. When I say y equals to 2, basically it is a horizontal line where each and every value is 2, right? So this was x equals to 1. You will see that this is a function since it passes the vertical line test, right? Now D is x equals to y square. Now in this particular case, what should we do? We should isolate y, right? So we need to isolate y. So what we get here is y equals to square root of x. Whenever you do square root, you have to do plus and minus. So for each value of x, we may get two values of y, right? Except for 0, of course, right? So this one is also not a function, correct? If you sketch this, what do you get? Plus minus square root x means it will be kind of like this. It fails vertical line test. If you draw a vertical line, it will cross at 2 points. Clear? Now the last one here is slightly tricky. You need to isolate y. So in this particular case, you can say y equals to 3 over 2x plus x over 2x, right? So you isolated y, which we could also write as equal to 3 over 2x, and here x and x will cancel, plus half. Is that clear to you, right? So it is a graph of 1 over x which has moved half units up. So this particular graph could look like what? Now this could be exercise for you, right? So here we'll have a horizontal asymptote at half, correct? And if I put x equals to 0, then we have undefined. So it is definitely not going through 0, right? So x cannot have 0. So we have a vertical asymptote here. Is that clear to you? Right? If x is very, very large, positive value, then it is going to approach half. So something like this you're going to get, right? Right? And when will this be 0? If I put y equals to 0, in this equation, I get x equals to minus 3, right? So the value of y will be 0 at minus 3, and I'll get a graph which is going to be kind of like this, where this value, where we have this x-intercept, will be at minus 3, and that is y equals to half. Correct? So that is a kind of graph, and you can clearly see that it is a function. Is that okay? So in this example, b and d are not functions. Reason being, they fail vertical line test. For a value of x, we have more than one value of y. Is that clear to you? Now let's take second example. In question number 2, which of the following relations given in the form of set of ordered pairs are not function? Explain. What should you do? So the strategy here is to check the x values, right? So strategy is x value should not repeat with different y value. Is that clear? So you just check for x values, right? So if they are all different, then it is a function, right? We are looking for not a function. We are looking for not a function. If it repeats, so they are all 3, 4, 5, minus 5 are different. 3, minus 3, 0, minus 1 are all different. 3, 2, 1, 0.5 are all different. 7, 6, 3, 6. Now 6 is repeated. They have different y values, 2 and 5. Therefore, this is not a function. So at 6, we have two values. So if you actually plot this, then what you will notice that at 6, when x is 6, in that case, we'll have two values. One is at 6, 2. The other one is 6, 5, right? So we have 6, 5 and 6, 2 vertically placed. And therefore, this is not a function, right? Now, in this one, 9 is getting repeated with 2 and 3. So this is also not a function. In fact, all 9s are being repeated. The values are 1, 2, 3, and 4, right? So this is also not a function. All the 4 points are on a vertical line. Is that clear to you? So these 4 points could be represented as, let us say, here we have 9, right? So we have 9, 1, 9, 2, 9, 3, and 9, 4. Is that okay? So we have all the points vertically placed, so it is not a function. Is that clear to you? Right? Okay. Question number 3. Which of the following relations about grade 11 students in a class is not a function? Explain. Shoe size of these students. Now, when we talk about any individual student, every student will have a different shoe size, right? So shoe size is different for every student, unique, right? Maybe. So if we can say a student will have one shoe size. So this is a function. Is it okay? We have to say not a function, right? So we are looking for not a function. So the first one is a function. Second, weight and height relation of students in a class. Now, If we have two different students whose weight is same, their height may be different, right? So for the same weight, we may have different height. Therefore, this is not a function. Is that clear to you? So that is how you have to figure out whether it is a function or not. C. Marks obtained by a student in first quiz of the functions, on the functions. So marks obtained for every student will get only one particular mark, so it is a function, right? So you cannot get 2 marks in the same test. Time studied, 2 marks obtained by the student in the class. Let's say there are 2 students who have studied for 2 hours, they may get different marks, right? Therefore, this is not a function. E. Subject taken by each student. A student can take more than one subject, and therefore this is also not a function. Is that clear to you? Correct? Question number 4. Relation between independent variable A and dependent variable B is explained below. Which of these relations represent a function? Explain. Now here it is important to understand that we are talking about independent and dependent variables A and B, right? So when we say independent variable A, then A is along the x-axis and B is a dependent variable along the y-axis. Is that clear to you? Now, which of these relations represent a function? So what you should do here is you need to isolate. So the strategy is to isolate B in terms of A. So we have to write B as a function of A. So technically, we have to write B as a function of A, right? So this is what you have to do. Perfect. So let's try to figure out. The very first one, and we are looking for which of these relations represent a function, right? So we want a function, represent a function, right? So first one, B is already written in terms of A as 2 minus A. This is a straight line. It does represent a function. It is a straight line, right? So a line dropping downwards. Second one, A equals to B squared plus 1. We have to isolate B. So if I do that, what do I get? So this could be represented as B squared will be equal to A minus 1. And from here, we can write B equals to plus minus. Whenever you do square root, you get plus and minus. A minus 1. As soon as you get plus and minus, we know it is not a function. Is that clear to you? Because for any value of A, you might get 2 values of B, right? Plus and minus. So not a function. Clear? Next one. If I isolate B in this case, what do I get? Let's use a different thing. So in this case, B is equal to minus A squared plus 5. It's a parabola opening downwards. We know it is a function and B is uniquely associated with every value of A. A equals to B cube root, that gives you B as what? So B is A cube, that is also a function. So we'll mark this as a function, correct? You may actually now graph these functions and practice. The last example here is 1 over A plus 1 over B equals to 1. So let's try to isolate B here. So we get 1 over B equals to 1 minus 1 over A, right? So I can write 1 over B as A minus 1. So when you flip this, what do you get? You get B as equals to A over A minus 1, right? So for every value of A, we'll have unique value of B, and therefore it is a function. Later you will learn this is a rational function. Perfect. So that is how we can actually answer this question. I hope the concept is absolutely clear, right? Now let's take question number 5. 2 more to go, 5 and 6. Now this is a tricky question. Domain and range of some functions, I should say some relations, is given. Each relation consists of 5 points. So there are 5 points in each relation. Explain which of the following are not functions, right? That is what. So we are looking for not functions, and we know This set represents 5 points. So 5 input-output points each, okay? Now let's answer this question. The first one is, domain has 1, 2, 3, 4, 5 unique x values and range as 3. We have more domain than range, so it is a function, right? This one is a function. Next one, domain is 1, 2, 3, 4, 5. Perfect. Now the range is 1, 2, 3, 4, 5. This is 1 to 1 relation. It is a function. Is it okay? So every value will be associated uniquely with some value of given in the range. Now here 1, 2, 3, 4, 5. So we have again 5 elements and domain are unique 5. Range may be same for each, right? This is like every element is, this is kind of like this. This is 0, 5, 1, 5, correct? 2, 5, 3, 5, like this, right? And 4, 5. So you can see that each element is unique. Every x value corresponds to only one value of y, so it is also a function, right? Next one, we have only one value in domain, so 5 repeats with all. So definitely this is not a function. Since for the value 5, we have 5 different values of y. Therefore, it is not a function. The last one here is 1, 2, 3, 4, 5 elements in the domain, and in the range we have 1, 2, 3, 4, 5, 6. That means some value should be associated with more than one, and therefore this is also not a function. Correct? So here what we learn in this case is if range has more elements than domain, then it is not a function. Is that clear to you, right? So clearly that means one element of domain is connected with more than one element in the range. Clear? So that is how we are going to answer this question. Now here's the last question for you to answer. This is very similar to question number 4. We are saying relation between independent variable A and dependent variable B is explained below. Which of these relations represent a function? Explain, correct? So again, remember this part that we're talking about A and B as our variables, where A is independent variable, B is dependent on A. So we have to see a relation. What is B in terms of A, correct? Part is A is directly proportional to square of B. So in the first case, if I have to write an equation, we're saying A is directly proportional to square of B. I write A equals to K times B square, correct? Now we need to isolate B, right? So let's get back to this. So we are writing A equals to K B square. A is directly proportional to square of B, so it is equal to constant times B square. We need to isolate B, so we get this as B square equals to A over K, or B equals to plus minus square root A over K, and therefore this is not a function, right? So which of these relations represent a function? This is not a function, right? Okay, so this is not a function. Is that clear to you, right? Next one. A is inversely proportional to B. That means A is inversely proportional to B means we write like this, right? Or you can say B is inversely proportional to A, or B is equals to some constant K times A. Well, that's a linear function. So this is linear function. So we'll mark this as our function. Is that clear to you? So likewise, you can do the others. C is product of A and B is a constant. So product of A and B means A dot B is equals to constant, let's say K. We need to write what B is. B is K over A. It is a function, right? So it is a rational function. We'll mark this. The next one here is square root of a is 5 less than b. So we are saying square root of a is 5 less than b minus 5, right? So we can write this b as square root of a plus 5, and clearly this is also a function, right? The last one here is a is 1 more than absolute value of b. So the last one is a is, let's write down like this. Okay, so we are saying a is 1 more than absolute value of b. So we need to isolate b now. So absolute value of b is a minus 1. Now, is that a function or not? How will you figure this out? Right? Now, there are a couple of ways to look into this. So at this stage, what you could do is you can have different values of a, right? So we are saying absolute value of b. So you could actually also start with this function itself. So what you will notice here is that for a value of a has to be, we may get two different values of b, right? That is possible. See how. If I say b is minus 1, let me write like this. So we'll write b and a, right? So we'll use the first equation. If I write b as, let us say minus 1, right? And calculate what is a equals to. Minus 1 absolute value is plus 1, so we get 2 here, right? Now, if I use b as plus 1, then plus 1 is also 2. So what do you notice here? We got one set of points which is for us, since a is independent, so we are saying 2 minus 1 and 2, 1 are on this curve or on this relation. Since 2 is repeated, this is not a function. Do you see that? So this one is not a function. Is that clear to you, right? So that one was slightly tricky, and I hope you understand the concept. What you could do in such cases is take some points and then figure out what kind of set you're getting. So ordered pair will show you that there is a repetition of the independent variable with different y values, and therefore this is not a function. Is that clear to you? So with that, we complete this topic on identifying whether a relation is a function or not. These questions were from previous test papers, and so I hope in your own test you should do fairly well with these practice test questions. I hope you understand and appreciate. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.